Hello, friends. Welcome to the platform of mathematics. We will continue our trigonometry session 2. In the last session of trigonometry, we have learned what are the standard ratios of angle in trigonometry called sine, cosine, tangent, and how to remember those ratios. If I again recapitulate trigonometry, session 2. Right. Now, we understood that sine theta was called P by H, cosine theta was called B by H. P is the perpendicular, H is the hypotenuse. B is the base and H is again the hypotenuse. And the third ratio is called the tan theta, which is P over B, can also be said to be sine theta over cosine theta. Because when I write sine theta value, it is P over H and cosine theta is B over H. This H and H cancel. So ultimately what you get is P by B. So this much we have learned. Now there are some standard angles in trigonometry and the students are asked to work on the numericals without consulting the table of the values for the trigonometry, and they have to remember all these values of standard angles. What are the standard angles? These are 0 degree. I write a little below so that I can show you the working, how to work out this and remember very easily. 0 degree is the first one, then is 30 degree, third is your 45 degree, 60 degrees, and the last one is 90 degrees. These are the 5 standard angles, and we have to remember the values for sine of that, cosine of that, and tangent of all these numbers. It is it will be very difficult to remember ultimately, but I show you a trick by which you can work out in 30 seconds and remember it and cross check also if you have any doubt in your examinations. So how we work out? We write from here 0, 1, 2, 3 and 4. The highest number I have written is 4. Then you keep on dividing every number by 4 like this and then take the square root. Now evaluate these values and write in this row of the sign. So what is 0 by 4? It comes out to be 0. 1 by 4 square root is nothing but 1 by 2. Square root of 4 is 2, so it becomes half. Here it will simplify as 1 by 2 and it can be written as 1 over root 2 because square root of 1 is always 1 and square root of 2 is under root 2. This one will become as root 3 by 2 and this is 4 by 4 which becomes 1 and the square root is also 1. So the values of these angles 0 degree, 30 degree, 45 degree, 60 degrees and 90 degrees for the line of sine theta has been calculated. So simply, see what I did. I wrote 0, 1, 2, 3, 4. Then I divided all the numbers by 4 and took the square root. Similarly, for the cos, you need not do anything. You simply reverse writing this line. The line which you have written in this left to right, now you write from right to left. So 1 will come here, then root 3 by 2 will come here. 1 root 2 remains static at this position, then comes your half, and then comes your 0. This is what is cosine. Now, to find the tangent, what we do is, we see tangent is sine theta by cos theta. See here, this ratio. So you divide the value of sine by cosine. If I divide 0 by 1, what I get is a 0. When you divide half by this, you get 1 over root 3. When you divide this, you get 1. And here you get only root 3. And this is 1 over 0 is not 0, it's not 1, but it is infinite. 0 can divide 1 infinite times of numbers. So we will write undefined or infinity. Now this is so simple, and in case you have to find the value of the reverse of this, say cosec, then sec and cot. What you do is invert all these values. So 0 will become 1 by 0, so it is 1 by 0 was infinity. This will become 2, this will become root 2, this is 2 over root 3, and this remains as 1. 1 over 1 is 1. Similarly, for the cos line, you inverse the values. 1 by 1 is 1. This is 2 by root 3. This is root 2 again. And this is 2. And this 0 will become what? 1 over 0. 1 over 0 is again infinite. For tan, I am writing cotangent, which is inverse of tan. So 0, invert it. 1 by 0 is infinity. 1 by root 3 is only root 3. This is 1. This is 1 by root 3. And this will become 0. So this is the total chart you get for all the sine, cosine, tan, cosec, sec and cot. This is so simple. Okay. Now I'll tell you what is identity. Identity is coming from the relationship of a right angle triangle where we apply the Pythagoras theorem. If this is P, this is B, this is H, and suppose this is a triangle called A, B and C, this being 90 degree and this angle is suppose theta, then by Pythagoras theorem what we write? By Pythagoras theorem, we can write H square is equal to P square plus B square. That means hypotenuse square is equal to perpendicular square add to the base square. Now if I divide both sides by h square, then what is happening? Nothing will change. This ratio will become 1. This p by h whole square, and p by h whole square, just before it you saw it is called sine. So sine square theta plus b by h is called cos, so cos square theta. Now this is one very important basic identity in trigonometry. Why it is called identity? Because this relationship is valid for any number of theta values. Any values of theta, this is valid. How we show it? Suppose I am applying for this angle 30 degree. Sine, tan, cosine, everything. Now tan is not there, sine and cosine. Sine square is half square. So for this I write for 30 degree, this is half square plus root 3 by 2 whole square. What will become 1 by 4 plus 3 by 4, which is 4 by 4 and is equal to 1. So this is verified. Similarly, I check for suppose another angle 60 degree, or I am just removing this to find out for 60 degree. 60 degree the values are like this. So sine of 60 degree, sine square 60 plus cos square 60. How it will look like? This will be sine square is root 3 by 2 whole square plus half whole square. It will again become 3 by 4 plus 1 by 4, which is 1. You can apply and check anywhere. That is why it is called identity. No more theorem or no more equation. Equations are separated by equal sign, but here in trigonometry, this type of formulas we will call as identities. Now, how many identities are there? I'll just show. From this only we will come to different types of identity. First one, if it is the first one, primary, sin square theta plus cos square theta is equal to 1. Then I can write sin square theta is also equal to 1 minus cos square theta by transfer of the terms. Similarly, I can say cos square theta is equal to 1 minus sin square theta. And in the first one, if I divide it by sin square theta or by cos square theta, what will happen? I am dividing both sides by cos square theta. Then what I get, just see, it is another identity and we call it as tan square theta plus 1 is equal to sec square theta. And from here again we write by interchanging of the terms. So this is how we create the identities. Nothing to memorize, very simple to work out, and you can verify as well. We'll talk something more about the applications in the next session. Thank you very much for watching.